Good afternoon, students. So, welcome to 18 ECL 47 microcontroller lab. So, in today's session, we'll see how to execute 8051 programs which are written using the assembly level language using the Keil software. So, here on the desktop, you can see the Keil software which is installed with the version 3. So, here using this software, we will be writing the program and we'll see how to see the results for the written programs. So, here when you click on this icon, so here you can see the window like this. So here first we need to create a project. So after creating the project, then we can use an editor to write the program. So here two tasks has to be performed. So here first let us create a project. So go to project, as you can see on this taskbar. So here we have a project. So here in this, select a new project, and here I'll be creating the new project in the D drive. So here let me select the D drive here. So here go to D drive and here create a new folder in this. I'll just give the folder name as KJK. So here instead of this giving the general name, you can give your USN as the folder name, and within that folder you can create a project. So here I have opened this folder. Within this I'll be typing the project name. So since our first program is the data transfer, so I'll just give the project name as data transfer. Any name you can give. So here I'll be giving the data transfer. So and select save. So when you do that, one more window will open. So in this we need to select the device that we want to use for simulating the program. So here we will be using the microcontroller which are provided by the Atmel company or Atmel manufacturers. So here you can see the various manufacturers are available here. So here out of all this, so here we'll be selecting Atmel. So in this we'll be using 8089C51. So here we'll just check for that 8089C51. So here you can see that. Just click on 8089C51. So on the right side you can see the related features of 8089C51 microcontroller. So it is a 8051 based microcontroller with 2 timers, 6 interrupts and so on. So with this feature, so here select this device and say OK, and here it will ask whether to copy the standard 8051 startup code to the project folder and add file to the project. So it is not required. So here you say no. So after that, here on the left hand side in this project workspace, you can see the project has been created, and also at the top of this here you can see that the project is been created with the name data transfer. So after this, so here we need an editor in order to write the program. So here that can be selected here. So you can see the icon. Otherwise you can go to file and select new. So here here you can see the new window that is been opened. So here in this you need to type the program. So I'll type the program, simple program here. So after writing the program, so the next step is we need to save the program. So here once again go to file and select save as. So here directly it will be giving the path to the folder where you have created your project file. So here in this give the program name. So here I'll just select the program name as P1, and you can save this with the extension .a51. So .a51 in the sense whatever the assembler compiler which is designed for the 8051 or 8951, so that will be used here. So here select the file name or save the whatever the written program you have, so that will be saved with the extension p1.a51. Save it. So now you have saved the program, but here this program is separate and whatever this project we have, so that is separate. So here now we need to attach this program to this project. So here what we do is right click on this, select add files to group source group 1. So here it will be asking files of type at the bottom. So here just select the assembly source file. So here you can see whatever the assembly file that we have stored, so that will be displayed here. Select, click on that and select add. So now close this. So here if you click on this plus icon, you can see the program that is been attached here. So now the program and the project and the program files are related, are connected with each other. The next step is here we need to check whether any errors are there or not in the written program. So for that, here we just go to this build target, or otherwise in the project taskbar, here you can see that option build target with, or else you can also go with the option F7. So here build target. So here if any errors are there, so at this window it will be displayed. So since there are no errors in the program, so here we will be getting 0 errors and 0 warnings. So here for example, I'll just write R9. As we know, only we have the registers from R0 to R7. So here I'll just write R9 and we'll see whether we'll get the error or not. So here build target. So you can see the undefined symbol. So this is an error. So target is not created. So if any error there, if any errors are there, so it will not be compiled. So here you just change that and make it as the original, and once again build it. Whenever you will be changing the program, so always save and build it, otherwise it will not be considered. So build, and again beside this we can see rebuild. So here it is going to link all the related files. So after rebuild, so next is we need to execute this program. So here for that, go to debug. At the top you can see the debug option. So here in this, click on the start or stop debug session. When you click on this, so it will be asking evaluation version running with the code size limit 2 kilobytes. So say OK. And now we need to see the results of this step by step. So here in this program, a simple program is been written. So here we are using R0 and R1 as pointers which are loaded with the value 30 and 40H. So here you can see, when in order to see the results step by step, here you can use the function key F11. Here you can see step, in order to see the results step by step, you can use the function key F11. So that is available in the keyboards which are connected to the computers. So here I'll just go on pressing the F11. So here you can, at the same time, here on the left side you can see the various registers. So here you can see the registers R0 to R7. Initially all these registers, they are loaded with the value 0, and also as I told, so by default all the registers, they will be used in the bank 0. So if you want to use the same registers R0 to R7 in bank 1, bank 2 or bank 3, then we need to set the third and fourth bit of the PSW register. And along with that, you can also see the system registers, register A, register B, stack pointer, DPTR, program counter, and so on. So and also here you can see the program status word register. So here RS and R0, you can see that. So here by setting and resetting, you can select the relative bank registers. So here as of now we will be restricting onto only the bank 0 registers. So here when you click on F11, so here you can see that we are moving 30H, that is hexadecimal value, that is taken into the R0. So here you can observe at the left side R0 is loaded with the value 30H. And similarly, when you click on F11 for the second time, you can see R1 is loaded with the 40 value. And next, so here now as I told, R0 and R1, they will be used as the pointers here. So here pointers in the sense they will be pointing to the RAM location. So here at the bottom of this window, here you can see the address. So here you can see the code memory also. In order to see the code memory, here you need to type C:0x12H. For example, I am writing. When you write 0x12, so automatically it will be taking all the values in the hexadecimal. So simply if you write 12, it should be followed by H. So then also it will be jumping to the same location. So yes, C stands for the core memory. So whenever you want to see the core memory, you can type C:. And if you want to see the results of the data memory, that is the RAM location, then you need to write D:, since R0 and R1, they are loaded with the value 30 and 40, here I will be typing 30H. So here you can see that, so here the address, it is pointing to the 30H location. So here you can see D:0x30. So here the first location is 30, next one is 31, 32, 33, 34, 35 and so on. So here one. So now in the program here we have written move a comma at r0. So here at r0 in the sense the pointer now it is pointing to the memory location 30H. So here we have 0 here. So here you can load any data here. Just click on this and type the data. So for example, I'll write 45 and this 45. So that has to be transferred to the accumulator. So when you press F11 for the next time, so you can see that whatever the data present at this location 30H, that is moved to the accumulator here. So here you can see 45 is transferred to the accumulator which was present in the memory location 30H. So here the content will remain same at the same in this location 30H. It is not going to change. And in the next step, so here we have move at R1 comma A. So that is the contents of accumulator which is 45 that has to be transferred to the location 40H pointed by R1. So here just click F11. So here when you press F11, so here you can see at the location 40H. So here you can count this 30, 31, 32 and so on. So here at the location or here you can change the address D:40H. If you type this, so directly it will show the result of 40H. So here 45 is being transferred to the location pointed by the register R1. So yes, this is the simple program that we have written, and here I'll just go on executing all the programs. I just go on observing how the results will be seen in this window. And I'll take the next program. In order to continue with the next program, you just go to debug and select start or stop debug session. So it will be winding up, that is it will be stopping the current execution of the program and it will coming back. And here whatever the program that you have written which is been attached to the project file, so that can be removed. So here simply click on this whatever the program file we have. So right click on this and say remove file p1.a51. So it will ask sure to remove, say yes. So now every time there is no need to create the project file. So whatever the project file that you have created, to the same project you can attach the programs. So but the thing is you need to remove that, otherwise they will be overlapping, because every time you will be usually we used to write org00h. Even if you start the next program with the location org400h, so what happens is, so whatever the first program that is being attached, so that is going to be executed, and then it will be executing simply NOP operation until it will arrive at the location where you have written the second program. So in order to avoid that cumbersome, in order to avoid this complexity, so here we are going to remove the program that is previously been attached to the project file. So now we have removed, you just close this, and in order to write the new program, once again select a new file. So here once again new window is open. In this window you are going to type the program. I will see how to, I will just select a program and I'll just show how to do it. As let us take the second program. So here the program is to transfer a block of data from the RAM location 30H to another RAM location 40H without overlap. So here this program has been explained in the previous lab. You just write that program and go to file and select save as. Where you have to save, so within the project wherever you have stored. So here we have created a project data transfer in the folder KJK. You just save here as p2.a51 and select save. Now it has been stored, and now right click on this source group, add files to group source 1. So here make a change for the files of type, select ASM source file. So here we want to attach the second program p2.a51, select on that and click on add, and now it has been attached. So now the next step is build the program to see any errors are there, rebuild it in order to link all the available files. And next here you can see that, so here R0 and R1 they are used as the counter, they are used as the pointers, R3 is used as the counter, and we are fetching the data from the location 30H and that will be transferred to the memory location pointed by R1. So here we'll see how to see the result. So here go to debug select start or stop debug session, say OK. So now just use the button F11. So you can see R0 is loaded with the value 30H on the left hand side. When you click on F11 for the next time, R1 is loaded with the value 40 and R3 is loaded with the value 05, and clear the contents of accumulator. Next, here we need to fetch the data from the location 30H. So here at the memory, so here suppose if you don't see the memory here, so that can be taken. So here at the taskbar you can see the option view. So in the view we will be having various options. So here in this we'll be having the memory window. If you click on that, it will be giving the window like this. So here in the address toolbar, we just type D:30H. So here when you do that, so here it will be showing the various addresses starting from 30H. So here you can see that here we have all the values stored as 0. So here we should have some data that is to be stored here, and that has to be transferred. So I'll enter the data here. Manually we can enter the data. So here, so click on this. Just a minute. Enter the data here. I'll just type 45, and next I'll take whatever the data you want, you can enter here. 10 I will enter. Next 02, next 0F, that is hexadecimal value will be taken or character, and here I'll type 15, 42. I think I have entered enough data. So here this data which are located at 30, 31, 32, 33, 34, 35. So this has to be transferred to the location pointed by the register R1. So here now coming back to the program. So when you press F11, so you can see that we have written move a comma at R0. So here when you do that, so you can see, so whatever the data present at the location 30H, that will be bring to the accumulator, and that will be transferred to the memory location pointed by R1. So here you can see R1. So otherwise you take second memory window. Here you can see, type D:40H. So directly you can see the result here. In the memory window you will be having the input, and in the same window you can see the result, no problem. Suppose if you want the clear visualization, you can take up the second memory window, and in that you can type the relevant address and you can see the result. Just keep on executing. So here you can see that increment R0 we have written, increment R1 we have written. So here your R0 will be pointed incremented to the value 31, and R1 is also incremented to the value 41. And here when you execute DJNZ R3 comma back, so here you can see that, so here the contents of R3 which was 5, so it will be decremented, and if it is not 0, it has to go back to the label back. So here you can see, so R3 is decremented to the value 4. Since it is not 0, it has gone back to the label back, right? So once again, whatever the data that is present at the next location 10, that will be brought to the accumulator, as you can see here, and then that will be transferred to the memory location 41H, that you can observe. And similarly you can go on executing and seeing the results until the count becomes 0. So when count becomes 0, the program execution stops. So here you can see all the results that is being transferred from the location 30H to 40H location onwards. So this is the second program. Similarly, you can execute the next program, that is transferring the data with overlap. So first remove this file, say yes, take up a new file and type the program here. I just copy the program and save it with the p3.a51. attach this to the project file by doing the same procedure. And just add files to group source group 1. So here make the change ASM and select P3, close it, and directly use the button F7 to see the result. So here, since there is an error, so error, where is error? So here I have typed 3, that I'll remove, and once again I'll build it. So there are no errors. Rebuild and go to debug and select start or stop debug session, say OK. So now you can just maximize it, go on executing. So R0 30H, R1 35, R2 is 05, clear the contents of accumulator. Now we are going to adjust the pointer. So here you can see this. So here accumulator, it will be loaded with the value of R0, that is 30, and then it will be added with the contents of R2. Just a minute, hold on. So here we need to adjust the pointer. So here when you execute this R0, it is loaded with the source address 30. R1, it is loaded with the starting address 33H, and then load R2 as a counter, and then clear the contents. Take the R0, which is with the value 30H, into the accumulator, and here in order to adjust the pointer, so here we'll be adding A with the counter value, so that it becomes 35, and that will be transferred to the register R0, as you can see here, and then adjust the pointer of R1 to the last address. So initially 33, it is added with the count value 38, and then take that into the register R1, and then here in order to transfer the data with overlap, so here first you just store the data at the locations 1, 2, 3 and so on, at 31, 31, 2, 33, 3, any data you can take, and I am taking just these data. So here you can see, so here at the 30H, 31H, 32H, 33H, 34H, so these are the 5 data that we want to transfer, starting from the location 33H, that is, you can look at the memory 2. So here you can select the memory 33H here. So here we have only these 2 data. So from this location we want the data transfer. So here when you do that, when you click on F11, so you can see, so we are fetching whatever the content presented R0 into the accumulator. So here we are not fetching, so 34, five. So you can see all the data that will be fetched and that will be transferred until the count becomes 0, right? So here when you go to the memory 2, so here starting from 33H, you can see all the memory is been loaded here, except 1, since we have taken only the data count value as 5, and the destination address, it was at the last point. It is not showing the transfer of the first byte. So if you want that, you can take one more count for that, and you can see the result. And next here we'll go for the transfer of block of data from internal RAM location to another RAM location. So first stop this and remove the file. Yes, close this, take a new file. Here I'll just copy the next program, so that is the 4th program. Now to transfer the data, so I'll just type here, and after this you can save the program, save it. So go to file, select save, give the program name as p4.a51, and after that, so here one more is missing, I'll just include org 00H. That is, space should be there. So save and right click on this, select add files to group. So here select ASM source file, select P4 that has to be attached, close it, and then run the program to see any errors and rebuild it, and then go to debug, select start debugger session, and here just come back to this. So here you can see that R0 is loaded with the value, I'll just press F11, R0 with the value 30, DPTR is loaded with the value 4000, you can see. Next R4 we have taken as the count value with 5, and here in order to transfer the data from this 30H location to the RAM location 4000H, so first we need to give some data manually into the memory location, RAM memory location 30H and on. So I'll just give 75. Any data you can give, 80, 88, 90, 94. I think 5 datas are over, and here this has to be, this data, it has to be moved to the external memory location. So here in order to see the memory location content of external RAM, so you need to type x colon, here we have given the source address as 4000, so I'll just type 4000H. So you can see the 4000H location. So when you click on F11 and keep executing, so you can see that the first data 75, it is taken into the accumulator, and then that has to be transferred to the memory location pointed by DPTR. So go back to the memory 2 and you can see the data transfer, and similarly until the count becomes 0 you have to keep repeating, and in order to fetch the data from the next location you need to increment R0. Here you can see it is incremented to 31, and DPTR it is incremented to 4001. So if you are able to see it, that would be better. I hope you can see this. So fetch the next data 80, that is transferred here. Similarly it will keep transferring the data from internal RAM location to external RAM location. So here you can see that, so what are the data present in the RAM location 75 up to 94, that is been transferred to the DPTR location 4000, 4001, 2, 3, 4. So between these locations the data is being transferred. So this is the next program. Similarly you can go for the execution of the remaining programs, and up to this I hope you have come to know how to give the data, how to enter the data in the RAM location and so on. So one more last program I'll just see in order to show how to fetch the data from the on-chip ROM location, that is to find the largest element in an array. So after this or the remaining programs you can execute on your own. So to find the largest element in an array, so small change I have been made in the program and I'll be sending it to you. So in this program you can see that R3 is used as a counter in order to check each and every number to find out which is the largest element, and DPTR it is used as a ROM location. So here in the program you can see that at the location 8000 we have stored the numbers. So here we are going to compare these numbers one by one and we'll be trying to find the largest number. So here do the procedure as usual. So I attach the program to this and compile it, rebuild, and then after that if you don't find any errors just go to debug and select start or stop debug session. So here in this you can see on the right side on the LHS you can observe whatever the changes that has been made. So R3 is loaded with the value 0AH, that is nothing but the count value. Totally we are taking 10 numbers, and DPTR it is loaded with the value 8000 so that we can fetch each and every number which is present at that location on the on-chip ROM, and then clear the contents of accumulator, because Here, whenever you want to fetch the data from the on-chip ROM location, so we will be using the instruction MOVC. So whenever we want to use the MOVC instruction, so here you can observe it will be working in this format only, that is MOVC A comma at A plus DPTR. So clear accumulator and then 0 plus DPTR, that is 8000 is nothing but 8000. So here at this point you can observe at the 8000 location the first number is 0. So here that will be fetched here into the accumulator, so that you can see on the left side window, and then store that number into the register R1 and increment the DPTR, that is it will be incremented to the next location. Just a minute, F11. So it will be incremented to 8001 and then clear the contents of accumulator, because previously we have loaded with the value which is present at the 8000. So clear that, and 0 plus 8001 is, it will be pointing to the next location, and then fetch the data. So here accumulator, it will be having the value 6 now. So now that will be stored into the register R2 for the safer side, and then subtract the contents of accumulator, subtract the contents of register R1 from the accumulator. So here in accumulator we have 6 and in R1 we have 1. So here 6 minus 1, it will not be generating any carry. So here since there is no carry, so here it will be taking whatever the new value that we have fetched, 06, into the accumulator, and then that will be stored into the register R1, and then decrement the count value. If it is not 0, go back here, and here increment DPTR 8001, it will become 8002. Clear accumulator, because it is having the value 6 now, so clear that, otherwise it will not be pointing to the exact location where we want. So here 8002 plus 0 is nothing but 8002. So the next content is 5, that will be taken into the accumulator, store here for the next purpose. So here subtract the contents of accumulator. So in the accumulator what we have 5. So here 5 minus 6 is, there will be carry. So here since there is a carry, it will jump, it will not exchange, because out of 6 and 5, 6 is the largest. So decrement the count value. If it is not 0, go back here, keep on executing this, repeating this until the count becomes 0. So R1, R3 is the count, so R3 is 3 now. So out of the given number, 11H is the largest in this array. So here you can see the result at 8062. So here as you can see that in this last lines of instruction, we have loaded DPL with the value 62. So here at 8062 we will be finding the largest number 11. So this is how we are going to execute the programs using the Keil software. And one more program I'll just show in order to show the ascending and descending order program. So for that we'll just stop it. So I have written a program to arrange the numbers in the ascending order. So here suppose if you take 5 numbers in order to arrange in the ascending or descending order. So here for example, if I take 5 4 3 2 1, so this has to be, suppose this has to be arranged in the ascending order like 1 2 3 4 5. So here in this case what happens, so when we take the first number 5, so it is going to compare 4 times, right? So here even when you take the next number, so it is also going to be compared 4 times. So here for that reason, so here instead of taking the count value as 5, even though you have selected the total number of numbers that is to be arranged in the ascending order is 5, so take the count less than 1, less than that of the number that you have taken. For example, if n is equal to 5, so here the count value, it will be taken as n minus 1. So here this program has been attached to the project file. So now compile it to see any errors, and then go to debug, start stop debug session. So here you can see the program has been started at org00h. R7 is loaded with the value 4, which is used as a counter. Then R0 is used as a pointer, which is loaded with the value 40H. So here starting from 40H up to 44H. So here we will be giving the numbers which are to be arranged in the ascending or descending order. So next R6, it is also used as the inner counter. So for that load R6 with the value 4. Then before executing this instruction, you need to load the data here. So here I will be giving the data like 5, 4. In any order you can give, there is no issue with that. 2, 1. So these are in the descending order right now. So when you execute, so here first it will fetch the data present at the location 40H, that is 5, that will be taken into the accumulator. Increment the R0 value so that it can fetch the next value, that is 4, and that will be stored in the location 50H. And then the content of accumulator, that is 5, it will be compared with 4, which is stored at 50H. If they are not equal, compare for the carry. So here 5 minus 4, obviously there is no carry, so you need to exchange that. So you take the number 5 into the memory location. New memory location is nothing but R0. Here it was incremented to 41. So now it will be moved to that location. So once again decrement the count value R0, decrement the pointer value to the 40H so that we can store the lesser number or the lower value number. So you can see that at this point you can observe, so 4 has come to the 40H location. And again since we are comparing the 5 number with the remaining numbers, you just increment the pointer to the next location. 40 into 41 ಆಗಬೇಕು. So here it will be pointing to this location, and decrement the count value. If it is not 0, you just go back. So fetch the number present at the location 41 into the A, that is 5 is taken here. Increment the pointer value, that is to the next location where we have 3 here. So that 3 will be taken into the 50H location. Compare it. If they are not equal, check for the carry. So if there is no carry, exchange it. Repeat this process until the first number is been compared with all the remaining numbers. So here you can see that this is the first time output 4, 3, 2, 1, 5. So here next after this, so once again here since the count value becomes 0, so it will go for the outer loop. So here R7, which is used as a outer loop counter, so it will be decremented, and again R0 it will be stored with the original pointer value 40H. So initialize the counter again, take the data from the 40H location, that is 4, and increment R0. So here R0, when it is incremented, it will be pointing to the location 41 where we have 3 here now. So it will be compared. If there is no carry, exchange the numbers. This process is going to be done until the inner loop becomes 0. So here you can see this is the second loop output, that is you will be getting 3, 2, 1, 4, 5. Similarly, when you just go on doing this until the inner as well as the outer loop counter becomes 0, so at the final you can see the numbers are arranged in the ascending order as 1, 2, 3, 4, 5. Similarly, if you just want the numbers to be arranged in the descending order, only the thing is you need to change it to JNC. That is, you have to check for JNC. So here for that also I'll just show. Once again debug, rebuild it, go to debug, start a debug session. I'll just arrange the numbers in the ascending order here so that you can see the result in the proper manner. I'll just directly execute F5 here. I'll take 6 and this is 8. Any numbers in any order you can take. So here when you press F5, I'll be showing the final result. Here you can see that it has been arranged in the descending order 8, 6, 4, 2, 1. So step by step you can execute and see the result. And similarly you can see the results of exchange of data byte and the block of data byte between the various memory location. I have shown how to see the contents in the code memory and RAM, internal and external RAM memory and so on. So here using those concepts, you just execute, type all the programs using the Keil software and try to see the results. And also here some programs has been changed here. Slight changes are there. I have modified it, so I'll be sending the newly corrected programs to you. You just type those programs and try to see the results. Thank you.